Okay, Assalamu alaikum again. So let's move a little bit fast. As we stated before that we have two sides, primary and the secondary, we have also to know that we have step up and step down transformer. For example, in this case, as you can see here in figure number 3, the number of turns here is larger than the number of turns at the secondary. So this type of transformer is called step down transformer. Now I don't want you to get confused here. As you can see, now the number of turns here, it is like secondary over primary. So I don't want you to get confused with what you have already taken in machines 1 and machines 2. Usually the turns ratio you took is like turns ratio equal turns of primary over turns over secondary. Here it's going to be opposite. Maybe they have different technique in United States or the National Electric Code, but we are going, even if you have an exam, it is better to use primary over secondary for the turns ratio, and it's going to be also for the voltage ratio primary over the secondary. Now, what my concern here is to understand the differences between a step up and a step down transformer. In this case, this is a step down transformer because the number of turns at the secondary is less. Now we have a rule, we already took it in machines 1 and machines 2, that if the voltage ratio is more than 1, then the transformer works as a step down transformer, and this makes sense. Now, because the V secondary is going to be equal the V primary over the voltage ratio. So if the voltage ratio, let's say like 2 or 10, let's say in this case is going to be 10, then the V secondary equal 120 over 10, and this is equal to 12. Okay, so this is a step down transformer. In other cases we may face like step up transformer. As you can see here, the number of turns at the secondary is going to be larger than the number of turns at the primary. So this is a step up transformer. Now my concern when we are talking about the distribution transformer, because our course is wiring, then we are talking about the facility which will be connected to the utility. The utility will give us a transformer, and then it will be connected to your facility. So basically we are going to work with a step down transformer, not step up transformer. The other thing we have to consider also in the transformers, in reality, we have the terms H and the X. Usually the H refers to the high voltage, which will be connected to the high voltage terminal, which is going to be the distribution line, and the X terminal will be the low voltage, which will be connected to the to your load. Also, we have to take into consideration the fact we have taps in the transformer, and these taps are, you know, like in order to decide the voltage and the turns ratio we are going to use in the primary or even sometimes in the secondary side. Again, I want to recall the fact that we are working with a National Electric Code standard. So basically we can find in the secondary like two coils, and we can short them together, connect them together, so we have this number of turns at the secondary. And most probably we are going to use like two coils and connect them together, and we will have a lot of benefits as we will explain it later. Okay.